What's up, Techmanics? It's Yaan, this is Cyber Coach. Look what I've done. This is Sauron's painting. No matter what you'll do, Sauron is watching you. If you want to know how to make such stuff, be as a Sauron. Watch what I'll do. So, it's time to draw the dark scenery of Mordor. I'm not an artist. Here's my last painting. It's a title. So that's why I printed the bigger one with the picture I found on the internet. Looks cool, eh? I know. So what I'm gonna do, I'm gonna stretch it on the subframe and put the frame on the top. Ta-da-da-da-da-da. Here is the frame. It's very important for me because I've taken it from my family portrait. Next, I stretch the canvas on the subframe and fix it with construction staple. I insert it into the frame and fasten with poles. To fix the spotlight on the back, I make a frame from the boards. I fix the boards to the picture with screws. I sketch a place for a cut in the picture. So, it's a very important step, guys, because if I make any mistake, it will be an end of the project. Until the end of the video, I'll tell you just jokes, I don't know. So, wish me luck. I'm feeling myself like a Sauron. So, to imitate the Sauron's look, you can make an one-eye ugly face, like this. My god, it's so stupid. Let's try again. So, to imitate the Sauron's look, I need the spotlight with the focused beam. I'll try this one and I'll connect it to my laboratory power supply. I need to apply 600 milliamps on it. Cool, it's okay for me. Except Sauron's eye beam was yellow. So that's why I will take the spotlights apart to extract 3 watts white LED out. Then I'll put 10 watts yellow LED on its place. After removing the plastic top and the bottom of the spotlight, I'll unscrew white LED from the platform. Then I'll make 2 metric holes to fix my new yellow LED. The radiator was on the back side of the platform because LED hits too hard. New LED hits even more. That is why I will increase heat dissipation with thermal compound. After soldering wires, I will check if it works. Nice! I can assemble spotlight's parts back, and now it's ready to terrify the souls of my guests. To capture person movement, there are a bunch of already existing solutions, but I want to highlight 3 types. Range meters. Most common are ultrasonic. You can find them in any car parktonic system. It consists of 2 parts. The receiver and the transmitter. The transmitter emits a signal which reflects from an obstacle and goes back to receiver. The distance can be calculated from the time it emits and to the time it receives. It will be the S. Passive interfered sensors or peer sensors. They identify the appearance of warm objects like engines, humans, or animals. Usually you can find them on the garage. Next one, computer vision algorithms. It can be found on the traffic cameras. These guys will send you the bill if you will increase the speed limit. In my project, I will use range mirror, which works on the light. First, I need to make my eye move. I will add 2 hobby servos to my spotlight. I will attach them through servo brackets. To measure the distance to an object, I will use sharp interference range meter with the measurement range from 20 to 100.5 centimeters. I'll put him on the servo through servo brackets. Okay, here's the idea. I will put my spotlight somewhere in the painting and my range meter above it on the top of a frame. Their moves will be synchronized, so when the range meter will detect any changes, he will stop directly at that point. So, let's connect them to my Arduino Uno board. Nice, it's ready. I'll program it in Xcode because I have forgotten how to write a code in Arduino IDE. First I'm going to make the servo gradually move to 180 degrees clockwise, then to 180 degrees counterclockwise. For servo that is installed under my range meter, I need a servo node. I will use count node to control the value of the servo. By changing the step pin value, I make the servo rotate from the left position to the right. If the accumulated value is less than 0, a positive value is added. If it is greater than 1, a negative value is added. I add the any node with the onboard pulse signal to start the movement after powering the device. With the clock node, I set the update time for the counter in order to smooth the servo's motion. Okay, now I need to make the servo stop when it detects something. I will add a node for my sharp rangefinder. It has a range of 0.3 to 1.5 meters. It's perfect for motion detection. I use clip node to get rid of all values outside the needed range. If the rangefinder value is in the range, a 0 is added to the accumulated value, thus stopping the servo. Next I add a second servo node for the spotlight, so that they can move in sync. Load a patch. So, it's time to test it. I solder spotlight's wires to a 12 volts adapter, and also to prevent both lights and the range meter from falling, I will fix them on a tape. Come on, chimp! Ha. Come on! Yeah! Come on, champion! Do you want a ball? Hey! Come on! I'm here! Yeah, cool, eh? It works. Little brother's watching me, and I want to say hello to Pixar and everyone who inspired me for this. And think about fuck. First idea I came up with was cold mist generators, such things used in home air humidifiers. I take the lunchbox and put 3 of them inside. I pour some water into it and turn mist generators on. The fun thing is that I don't need any complicated electronics to make them work. Now I need to close the box and wait.
12 seconds later.
Aha! What the fuck? No! It's not even close! I want to make Mordor, not the greenhouse. Nah. I knew about it, so look what I'm gonna use instead. This is a real party equipment. This machine can generate fog cloud for 3 meters forward. Huh? Go. Nice. Now it looks more realistic, like a real Mordor air full of ash. Cool. However, my motion capture with this range meter now looks ridiculous. That's why I'm going to upgrade it. I'm gonna use Raspberry Pi camera, and real computer vision algorithms for it. So, what OpenCV exactly is? It's an open source library that got a huge number of already existing and working algorithms, like face and smile recognition. It even got the algorithm which can recognize the person in the crowd. Ah, it's cool, yeah? So I've written the code, but it's quite huge and boring, so I won't show it. And that's why I'll try to explain you how my algorithm works. I use a rather simple algorithm that remembers each frame it sees at the moment and compares it with the previous one. If frames differ in any way, that means that something new appeared or moved in the camera's field of view. In other words, the movement was noticed. So that part of the frame which differs is the moment when and where movement occurred. Well, something like this. Now I need to fix the Raspberry Pi, the spotlight and the camera somewhere to the case and check if everything is working properly. Right in a nozzle! The funny thing that my camera will be at that place. Also, I will add a half of the ball onto my eye place. I'll do it just for fun. Then I fix power supply and voltage converter for my servos. I hang the painting and run the program. I connect the monitor, mouse and keyboard for debugging. Now I turn on the camera to see if it works. This rectangle here shows me that camera had caught and tracked me. However, I need to debug the code so the spotlight turned to the place where the square is. Now I'll turn off the light to check the tracking with the lantern. Hey Sauron! It works! Cool, eh? Now you can call me Yaan Tolkien, cause I made a Sauron. Okay, thank you for watching, guys. If you got some awesome ideas, I want to see them in the comments below. Don't forget to give me a big thumbs up if you love Tolkien, and be tech.